Hello, geometry students. Mr. Zacek back and better than ever. We are in the final lesson of Unit 11 on circles. This one's going to be a long one because we're going to do segments related to circles practice. You read the previous lesson with all the different things, but we've got a lot to go through here today. So the first thing is I want to look at common tangent lines. So a tangent line is a line that touches a circle at one and only one point. So when we have common tangent lines, they touch both circles. So we see in this first diagram where you have common internal tangent lines, which means they're between the two circles. So if we have some space between those two circles, then what you'll see is that there are two possible common tangent lines. So we've got this line here and this line. If the circles are touching at one point, then there's only one possible common tangent line that we have, and that would be just that kind of line that goes through and hits it only at one point. Now, depending on how the circles are, we also have external. So if we take this kind of first diagram, we looked at the internal, now we've got the external. So you'll see there's one line here. Okay, the same thing in this scenario. When they touch, that's not any different. When they overlap, it's not any different. All of those are the same. The only time we get one is when they're like this, where they both have that, one's inside of the other one, but they touch. Now the scenarios where there's no common tangent points, if you have here, this picture is, these are concentric circles. So if you have concentric circles, that means they have the same center but different radiuses. That would not be, or this other one where they don't touch here on this one, there's no common tangent points. So sometimes you'll be asked the question like, how many common tangent lines are there? And so what you want to see is that if, back to this kind of scenario number one, that there would be two from this internal and then two external, so there would be four of them. Okay, and then the one where they touch here, the second scenario, there would be three common tangent lines because you got this one here, the internal, and then two external. So we're going to go ahead and construct a tangent line. Now, one of the things this is a real key concept is that a tangent is perpendicular to a radius. So we all know that perpendicular lines, that means they're going to, form right angles. And this is going to factor into a lot of the types of questions that we answer because we're going to get right triangles. We could use it in some proof scenarios. So the first thing I want to do is figure out how do we construct a line tangent to a circle O at P. So if we take your straight edge, what I want you to do is just draw some line that extends out from O to P, and just extend that out a little ways. And what I'm going to do now is I'm going to grab my compass, and basically I'm going to make the perpendicular bisector, because the tangent and the radius are going to be perpendicular. So how am I going to do that? Well, I'm going to do that by making P the midpoint. So I go here and then I double this one out, and now I've got these two endpoints of my, let's move that there, two endpoints of the segment. And now we do our surfboard construction, where we open it up more than halfway, go up, and go down. Whoops, I think that moved a little bit. Come down here, and we flip it around. Probably doing this faster than me if you have a compass. So down here and down here. And then we take our straight edge and we connect those two. And I'm going to try to, I got kind of thick lines, so sometimes that's a little bit. And there we go. We've created a tangent line, and we did that again because these form a right angle. So that's the key. The tangent and the radius form right angles. So the second one is a little bit trickier. Construct a tangent line from P to circle O. So what I'm going to do first of all, it's kind of a similar process in starting. I'm going to connect O and P. And now what I'm going to do is we're going to construct the perpendicular bisector of this segment. So I'm going to, just to try to keep it a little cleaner, I'm not going to do the full surfboard. It's not wrong to do the full surfboard, but I got some other pieces of this construction. So I'm going to come up, I'm going to come up. Okay, now we've got here the perpendicular bisector of that segment that connects O and P. Just trying to do my best to get that there. So we'll call that, that looks a little bit off to me. So let me just try one more time. Here down to here. Okay. So what I want to do now is I want to create a circle that is, so that has that radius that is the length of from here to here. Okay, so if we see that and you flip it over here, see how we've got that same radius going on there. So now what we're going to do is I'm going to put my compass point here and I'm going to draw this circle. Okay, again, you see I'm off just a little bit. And now what I'm really interested in is this point of intersection. That's going to be what's called the point of tangency. So from point P, if I draw a line, you see how that creates a tangent line there at that point? And that creates a tangent line there at that point. And so that's how you can get your a tangent from that one out. So again, you draw OP, if we're just going to review that, you draw OP, you do the perpendicular bisector, you draw that circle, and where it intersects the initial circle, that's where you draw the tangent lines from. Okay, so I want to give you a little bit of an overview, segments related to circles formulas, okay? And let's just start off by defining these segments again. You read it before, but the first thing that we have is, let me get my circle tool. We've got a chord. So we've got three types of lines that I want to just make sure we understand, we know what these are. So we've got a chord, we've got a tangent, which we've just been looking at. And then the last one that we have is a, let me move this down a little bit, is what's called a secant. So chord, tangent, secant. So the chord has two endpoints on the circle. The tangent touches the circle at one and only one point. The secant has one endpoint on the circle and extends outside of the circle. So the first, setup that we need to understand is, what do we do when we have two chords that intersect? So any two chords that intersect, what's the relationship? I'm going to label these. I'll call this one A, B, C, D. So in this length, it's A times B equals C times D. That's one relationship that we need. The second relationship that we have to be aware of is when we have a tangent and a secant. And so in this case, let's call this A, let's call this B, let's call this C. And so if this is b and c, the whole length of this would be b plus c. So the way this formula works is it's a squared equals b times b plus c. The outside length times the whole length. Okay, this is how I remember this. Outside times the whole. Or you can think of the outside as the exterior length, this b right here. So I'm going to get a highlighter just to show you. Now, the last scenario that we have is we have a situation where you have two secants. So if here's a circle and you have one secant and then you have another secant, and so let's label this and let's call this A, B, C, D. Okay, in this case it would be B times A plus B equals C times D plus C. In other words, it's the outside times the whole equals the outside times the whole. So very similar to what you have going on with the tangent. Again, the outside length is just that exterior length that we have here of B and then C. Let's put it just in green. So C is this one. That's just the exterior length that we have there. Okay, so those three right here are the key ones that we're going to spend a lot of time working on here initially. Okay, so let's look at what we have. So in this case here, we have a tangent and then we have a secant. So it's the tangent squared, 18 squared, equals the outside length, 12, times the whole length of the secant, which would be x plus 12. Okay, so it's the outside length times the whole length, and when you have a tangent, it's the tangent squared. Okay, so you've got 18 squared is 324 equals 12x plus 144. So we subtract 144 from 324, we get 180 equals 12x, and we divide by 12, and we get 15 equals x. Okay, and this one, it's going to be 5 times x equals 4 times 10. And again, the way I think about this, I'll just draw it in a different color. It's like A, B, C, D. So A times B equals C times D. You want to get it in your head so that when you go to do this, you have, you're aware of what that is. So 5x is 40, divided by 5, x equals 8. What I mean by that is you want to understand how to set the relationship up. So number 3, same thing. We've got interior, we've got chords. So we're just going to multiply 18 times x equals 12 times 21. Again, the key to this is that the lengths are on the same chord that you're multiplying together. So you'll notice that these ones are here and these ones are over here. So 12 times 21 is 252. So this is 18x equals 252. When we divide by 18, so 252 divided by 18 is 14. Okay, so 2 chords. All right, so number 4, what do we have going on? Well, we've got a secant and we've got another secant. So what's the relationship with two secants? So it's the outside times the whole length equals the outside times the whole length. So let's figure out what the whole length is first here. In this case, it would be 8. In this case, it would be 4 plus x, or x plus 4. So if we did 4 times 4 plus x equals 3 times 8. So we get 16 plus 4x equals 24. When we subtract 16, we get 8. So x would be 2. That would be that interior length. Okay. So a few more, just getting practice. All right, what do we got going on? Chords. So 6x equals 9 times 8. Hopefully we're finding a little bit of this rhythm here. So 6x equals 72. We divide by 6. 72 divided by 6 is 12. Okay, what do we got going on in 6? Well, secants. So let's figure out what the whole length is, because that's going to be a part of it. X plus 5, and the whole length of this will be 10. So outside 5 times the whole, x plus 5 equals outside times the whole. So it would be 5x plus 25. We've got to make sure we distribute, equals 60. So then we're going to subtract 25 from 60. 5x equals 35. We're going to divide by 5, and x equals 7. Okie doke, moving on. So, number 7, here we are. We got some chords. Make sure we're multiplying the ones on the same chord. 6x equals 7 times 12. 7 times 12 is 84. 6x equals 84. We divide that by 6. X would be 14. Okay. So here we are again. What do we have? 2 secants. Let's figure out what the whole length is. 18. The whole length here is x plus 6. So outside times the whole equals outside times the whole. So this would be 6x plus 36 equals 7 times 18 is 126. When we subtract 36 from that, we're going to get 6x equals 90. And when we divide that by 6, we're going to get x equals 15. Now, I just want to point out, though, one of the things that can happen in this case, we're going to see it in number 9. So let's just go ahead and do that one. Okay, what's the outside length here? The whole length is x plus 6. So watch what happens here, number 9. This is important. So x times x plus 6, that's the outside times the whole. And then over here, the whole length is 8, equals 5 times 8. So this is a case where now we get a quadratic. X squared plus 6x equals 40. So this is x squared plus 6x minus 40 equals 0. So what do we have for our options to solve? Well, we could factor it. We could use the quadratic formula. We could complete the square. This one to me is a shortcut case. It looks set up for factoring. X squared and negative 40. So what are the factors of negative 40 that add to be positive 6? Negative 4 and 10. So negative 4x and 10x. So this would be x and x plus 10 minus 4. So we'd have x minus 4, x plus 10 equals 0. So x minus 4 equals 0, x plus 10 equals 0. So this would be x equals 4, and x equals negative 10. We're going to reject the negative because it's a distance, and you can't have a negative distance, and therefore x equals 4. So same thing here, x plus 10. Okay, now this is a tangent, so it's the outside times the whole length equals the tangent squared. You could actually think of the tangent as outside times whole, because in the tangent, the outside length and the whole length are the same. So we get x squared plus 10x equals 144. So x squared plus 10x minus 144 equals 0. Now, one of the reasons why I think factoring is helpful is when you're factoring, you want to find the factors of negative 144 that add to be 10. And so you can do that as long as the number in front of x squared is 1. We don't have to really draw the box. We can just do it that way. Let me show you a little calculator kind of hack to help you with thinking through that. If you put in a graph and you do negative 144 and you divide it by x, okay, You've got that graph. You probably are not going to see it, but we go to the table. What we're looking for are, what are the factors here that are going to add to be, what was it, 10? And so it looks like 8 and negative 18. So that would be what we're looking for here. So it would be x minus 8 and x plus 18 equals 0. Just had to switch the signs. So x minus 8 is 0, x plus 18 equals 0. So x would be 8, or x would be negative 18. And again, we reject the negative because we're talking about a length. Okay, so lots of stuff right here. Really important page just to help you get a hold of this. And 9 and 10, these quadratic ones. Again, if you have a hard time with factoring, go ahead and do the quadratic formula. All right, now we're going to do some with these tangent lines. So here's the deal with tangent lines is that tangent lines are equidistant from the circle to the point of tangency. What does that mean? That means this and this are the exact same length. So if that's 6.3, this would be 6.3. If this one is 6.4, this one would be 6.4. So we can go ahead and, figure out what this piece over here is, because this one and this one are going to be equal. So if I did 15.3 minus 6.3, I'd get 9. So therefore this side is 9. So when it's asking for the perimeter, now we just add all of those up. So 9 and 9 and 6.4 and 6.4 and 6.3 and 6.3. If we add all those up, 9 plus 9 plus 6.4 plus 6.4 plus 6.3 plus 6.3 is 43.4. Okay. So I'm not going to do all of these, but I'll just do one more. I think you can get the idea pretty quickly here. Look at number 14. We've got 11. How are we going to do this? Okay, 6.8 is going to be this side. 9 would be this side. So if I did 13.5 minus 9, this piece would be 4.5, which means this piece would be 4.5. And then 11 minus 4.5, so we got 6.5, 6.5. Now how you want to add those together is kind of up to you. Like, just make sure that you get them all in. So if you want to go ahead and do this as 11 and 13.5, 9, 6.8, 6.8, 6.5, maybe that's a little bit of a quicker way of doing it because we already know the sum of two of those sides. So 11 plus 13.5 plus 9 plus 6.8 plus 6.8 plus 6.5 is 53.6. Okay, so that's the perimeter. All righty, now a little bit of a different take here on this. Assume the lines solve for x. So what are we doing here? We're highlighting the fact that this relationship, that those are equal to each other. So 2x plus 7 equals x plus 15. We go ahead and solve that, and we would get x equals 8. Okay. Same idea here. Again, these are equal to each other. So 3x plus 2 equals 2x plus 5. Subtract 2, subtract 2x. So we get x equals 3. All right, now a little bit of a different thing here, and looking at a different relationship. Find the segment length indicated. Assume lines which appear to be tangent are. So here's the idea that we need to keep in mind is that this is, so here's the big thing. The tangent is perpendicular to the radius. Well, what do we know about right triangles? We know our Pythagorean theorem of the sum of the legs equals the hypotenuse squared. So this question mark that we have here, let's call it A. So A squared plus 9 squared equals 10.6 squared. So 9 squared is 81. 10.6 squared is 112.36. So we would subtract 81 from that. A squared is going to be 31.36. And we would take the square root of 31.36, and A would be 5.6. Okay. So that's the same idea that we'll do in this question. This time we're looking for this out here, so it's still a leg. So this would be x squared plus 11.4 squared equals 19 squared. You always have to be careful to identify your hypotenuse correctly. So x squared plus 129.96 equals 19 squared is 361. So we're going to subtract 129.96 from that. So x squared is going to become 231.04. And then we'll take the square root of 231.04, which will be 15.2. Okay, so again, key thing here to recognize tangent and radius form a right angle. Okay, so what's going on here? Determine if line AB is tangent. Well, if it's tangent, then it forms a right angle. If it forms a right angle, excuse me, sorry about that, I had to sneeze. If it forms a right triangle, it'll satisfy the Pythagorean theorem. So the question is 9 squared plus 12 squared, does that equal 16 squared? That's a question mark. If it does, then we've got ourselves a right triangle. So 9 squared plus 12 squared is 225. 16 squared is 256. Those are not equal. So, therefore, it's not tangent because it would have to be a right triangle. So would this one be a right triangle? So is 12 squared plus 16 squared, does that equal 20 squared? Okay, so 12 squared plus 16 squared is 400. 20 squared is 400. So yes, AB is tangent. All right, now the last thing that we have going on here is when the radius is perpendicular to a chord. So here's the idea that we have going on with this. Again, this is in the previous lesson's notes. So when a radius is perpendicular to a chord, it is the perpendicular bisector. Of that chord. So what we have going on is we've got a right triangle that's happening. So we want to find the length of the segment indicated here. So very simple in this first one that we're looking at here, question 21, notice this right triangle. So this is our hypotenuse, these are our legs, so it would be 18.4 squared plus 6.7 squared equals x squared. So 18.4 squared plus 6.7 squared is 383.45. And then we're going to take the square root of that answer, and we'll get 19.5819 equals x. So we took the square root and said round to the nearest tenth, so 19.6, okay, would be our value for x. Okay, so same thing we have going on in 21. Here's C, call this A and B. So again, x squared plus 12.3 squared equals 22 squared. So just a little different algebraically, 484, 12.3 squared, 151.29. So we subtract 44 minus that value, and we get x squared is 332.71. And we take the square root of that value, and we're going to get 18.2 when we round it, 0.24. Okay, now 23 and 24 start to get a little bit more complex in this case. So what's happening here in 23 is I need to find this value of x. So how are we going to do that? Well, here's what I want you to see is that this, we could form a right triangle and that all the radii, here's the thing you got to keep in mind. So all radii are equal. So that means this is 11.1. I'm going to call this length A. So here's how I'm going to go about this question. So A squared plus 10.3 squared equals 11.1 squared. Okay, so we've got 10.3 squared. So A squared plus 106.09. 11.1 squared is 123.21. So we're going to subtract from that 106.09. Hang on. And I get A squared equals 17.12. And then I take the square root of that value. And so A is 4.113763. So how are we going to find x? Well, what is x? Notice that this is also a radius. So x plus a has to equal 11.1. X plus a has to equal 11.1. Well, I just found what a is. 4.1376 equals 11.1. So if we subtract that from it, we're going to get x equals 6.96. And if we're going to round that to the nearest tenth, that would round up to 7.0. Okay, so 24 is a very similar type of question, except for now we're given the diameter. So half of the diameter is going to be 10.1. And what happens here is this will be 8 because this is the perpendicular bisector. So again, we know this is going to be 10.1 and this is going to be A. So we could find that length. All right, I'm not going to do that one because I just did, the same type of question, but you see how it's set up. Okay, and all of these right here follow that same kind of reasoning. All right, I think we've sort of gone long enough here with this lesson, and you're going to get practice with it more and more. So I'm not going to do these, but we'll get a bunch of practice in class. So with our assignment, so make sure that you ask questions, right? So covered a lot here. If you have to go back and watch a specific part of it, there's a few different things that are in here, so we need to get them straight. Make sure you're asking questions, and apologize for the length of this one, but the good news is this is our final lesson here for this unit. All right, I'll see you soon.